tonight we're going to be doing the extra work in the back of the book, the chapter for greatest common factor of each pair of monomials. First pair is 63 and 84. So I'm using my drawing utensil here. And, well, first thing we got to do is find out what these all break down to. And if I take 63, I know that, well, they're divisible by 3 for sure. Or it's divisible by 3 because 3 and 21, right? If it's divided by 3, that'd be 21. So divided by 3 makes 21. And if I was to divide 21 into 3, then that would be 7. And I believe that's it. 7 times 3 is 21 times 3 would be 63. All right, so let's try 84 now. 84, can I divide it by 3? That is a question here. If I divide 84 by 3, and I'll just use my calculator real quick. 84 divided by 3 is going to give me 28. So I can divide it by 3. And 28, if I divide that right, then that would be, I think 4 times 7. 4 times 7. So now we have to find out what is the greatest common factor, knowing that these are the things that make up these numbers here. And let's not forget P. I almost forgot that. P is over here, so that means times P over here. And all these are multiplied to each other, even if, excuse me, even if, I got to make the thickness a little bigger here to show that. So now we have 3 times 3 times 7 times P, and 3 times 4 times 7. I believe now we got to go ahead and circle the things that are in common. So we will circle our 3's here because we see the 3's are in common. And we'll circle the 7's because the 7's are in common. And that's it. And 3 times 7, that's 21. So our greatest common factor for number 18 is 21. All right, let's go ahead and check out number 20. I'm going to do all the even ones today. We got 60JK. So if I take 60, what makes up 60? Well, we know that 10 and 6 make up 60. But really, you can break down 6 even more by saying that 3 times 2 equals 6, right? So 3 times 2 times 10. Let's see. And this is JK. Let's not forget that. So this is going to equal 3 times 2. That would be 6. Times, well, 10 is really 5 times 2. Okay. And then times J, and then times K. Now let's do 45. 45 JKM. JKM. And 45 can be done by multiplying 9 times 5, but 9 can be done by 3 times 3. So we got 3 times 3 times 5 times J times K and times M. Let's circle all the things we have in common again. We got the 3's in common, got the 5's in common, and really nothing else as far as numbers. So that tells us the numbers are going to be 3 times 5, that's going to be 15. But we also have the J's here, and we have the K's. So they will also be part of that. So the greatest common factor for these two terms will be 15 JK. And we're off to number 22. Number 22 has 54 GH and 72 G. So 54 G and H. Let's see, 54 can be made up by, let's see, I'm going to say 9 times 6. And if that's so, then we can say that 3 times 3 is 9, and 3 times 2 is 6. So our factors would be 3, 3, 3, and 2, and then they would be multiplied to G and H, of course. Let's try 72 now. 72G. Well, 72 can be found by 8 times 9. So 9 is 3 times 3. And then 8 would be, 4 times 2. And then we're going to multiply everything to G. And if we circle all the things that are our greatest common factor again, we'll see we have 3. We'll see we have another pair of 3s. We'll see we have this pair of 2s, and we'll even have G. So, well, 3 times 3 is 9, and 9 times 2 is 18. So our greatest common factor, we know the number is going to be 18, and G is left over, so 18G. All right, let's go ahead and go to number 24. 24, it says 5x plus 5. So they're wanting us to go ahead and find what factors it out. In this case, we're going to put things in parentheses. So if we put things in parentheses, we know that both of these have 5 in it. So I'll put the 5 on the outside and make it x plus 1. Now 5 times x is 5x, 5 times 1 is 5. Let's go to 26. Got 4x minus 7. 4x minus 7. Well, how do you factor this out? And the easy answer to that is you can't. There's really nothing that factors into 4 and 7. So I'm going to put cannot factor out. All right, let's move on to number 28, 32 and 24. Now, there's something definitely that goes into 32 and 24, and I'm going to say it's 4, because I know that 8 times 4 is 32, and I know that 6 times 4 is 24. So let's try that. We can say that, let's see, we said 4. And I'm going to even go a step, hold on, let's check this out. 4 times 32, we said that would be 8x. And then plus 6y. But both 6 and y have something in common too, don't they? And that would be 2. So we can factor that 2 out as well. Let's see, if we did it the way they told us to before, this would be, let's see, I'm going to backtrack here. I know this is uncharacteristic of me. Let's see. I'm going to erase this. And we're going to go ahead and work this out. With 32, we know that it's 4 times 8, and that's really times 4 times 2, right? Yeah. Really, these are 4 times 4. But we're going to look this over here real quick, because these will be 2 times 2 and 2 times 2. So that's like 2 times itself. 1, 2, 3, 4, 5 times. Over here, though, this is going to be 4 times 6. And 6 could be 3 and 2. And that's where we start finding our factors again. We've got our 4 here, we got our 2 here. 4 times 2 is 8, so we can go 8 into both of these, and that's going to be 4x, because 8 times 4 is 32, and then plus 3y, because 8 times 3 is 24, and that is about all we can factor. Let's move down the page and see what we can do more. All right, number 30 says, James has $120 in his savings account and plans to save X amount of money each month for 6 months. The expression 6x plus $120 represents the total amount in the account after 6 months. And that's accurate, don't you think? They're saying he has 120, and then for 6 months, that's the time, and we don't know how much he's going to put in each month. So now it's saying factor the expression 6x plus 20. And if we do that, well, we know that 6 goes into 12 twice, so it will go in 120 20 times. So we can say that 6 times x plus 20 will be our term factored out. And we're going to just make this a little thicker for the next one. Number 32. Number 32 says, write an expression in factored form that is equivalent to the given expression. Show your work on a separate piece of paper. Well, this says 1/2 x plus 4. How can I factor this out? Well, I could say I'm going to factor out 1/2. And if I did, well, I would multiply it by x to get 1/2 x. And now I have to say, what would I multiply to 1/2 to get 4? Well, half of 8 is 4. So I would say 8. And that would be my expression. Let's go to number 34 now. 34 says 34x minus 24. So once again, I can factor 3/4 out. And if I do, I'm going to multiply it to x in order to get 3/4 x. Now we have a negative 24, so automatically we know this is going to have to be a negative number that we're multiplying it to. And what can I multiply to negative 20, or to 3/4 to get negative 24? Well, most of you might have figured out over here, this was 8 divided by 2. So over here, this is going to be this is 4 times 2, which gives us 8. So 24 times 3 over 4 is going to give us our answer here. So let's go ahead and try to work that out. And we have to remember that we're really multiplying it almost like when we're dealing with the reciprocal. Okay? So just like over here, it would be like if you get rid of it, we're dealing with for 4 over 3. We're going to multiply this side to 4 over 3. So what is 24? Negative 24 times 4. Well, let's try it here. 24 times 4 equals 96. And then we're going to divide that by 3. That's going to give us 32. So I'm going to write 32 here. And I believe that's our answer. Let's see if that's true. If I was to go ahead and say 3/4 divided 3/4 times 32, would that equal 24 on my calculator? Would I get the right answer? Let's check it. Well, 3 divided by 4, remember every fraction is a division problem, equals this, 0.75, and then we're going to multiply all that to 32, and that gives us 24. So yes, that'll give us negative 24 in the end. We have one last one to go, and that's 2/5 x plus 16. So once again, we're going to take 2/5. We're going to multiply it to x. Now, what times 2/5 would give us 16? Let's not forget what we did over here. We multiplied our denominator to the number and then divided it by the numerator. So let's try that. This time we have 16. Let's see. Calculator. So this time we have 16 times 5. And let's see, divided by 2. So we should have 40. So I'm going to say plus 40. And, well, shall we see if that works? 2/5 times 40, will it give us 16? If we use our calculator, 2 divided by 5 equals 0.4 times 40, that gives us 16. Perfect. And that's all of it. The rest is on you guys to do, and I'll see you next class.